Right, welcome to Ignite 2023. Hope you have had a good Ignite so far. My name is Dave Glover. I'm a cloud advocate based in Sydney, Australia. My LinkedIn ID there is Gloveboxes, and I'm GitHub Gloveboxes as well. So the session, hopefully you're thinking of joining, is about improving results with vector search and Azure Cog Search. You might want to take a screenshot there with the link to that. Now, we're also joined today by Ruth. Ruth, do you want to tell us a bit about yourself?
Sure. Thanks, Dave. Hi, everyone. My name is Ruth Yakubu, and I'm a principal AI cloud advocate, similar to Dave. We're actually colleagues. And the best way to get a hold of me is via LinkedIn, but also with Twitter. So my Twitter handle is Ruthie Yakubu.
Awesome. So we've got, I'm based in Sydney and Ruth is based in New York City. And we're kind of thinking that the time zone where you're most likely to be is up through the Asia Pacific region and the Americas. I think that's probably the main time zone that works for this. But obviously this session will also be available streaming. So fingers crossed you've taken a screenshot of that link there, which has got the link to the live module. General suggestion is actually just follow on with our talk and go and check out the module after. Also, say hi to 𝗬𝗲𝗀𝗳𝗃, who's our wonderful moderator. You can connect with him on LinkedIn as well. And this session is live. So your questions will come through. 𝗬𝗲𝗀𝗃 will do his best to answer some of your questions, but he'll also pass through some of your questions through into the chat for us. And we will do our best to answer your questions as we go, or we'll look at them and try and answer them at the end. So do feel free to give the Q&A a go. Feel free to say where you're from or what you do, or just tell us a bit about yourself, what you're interested in. That was also always awesome to hear. Okay, so we had the screenshot for the link. And Ruth, you want to tell us a bit about what we're going to be learning about?
Sure. So the objective of this lesson is by the end of this session, what we hope for you to understand is what is semantic search. We hear about semantic search. What exactly is it? Then the next thing is leave with the understanding of vector search. I'm sure, especially now with the popularity of large language models, we're hearing vector databases a lot. So the good thing is hopefully by the end of the session, you'll be able to understand what vector search is. Then also embeddings when you're dealing with machine learning, and also needing to embed your text or whatever assets that you have. Also, one thing that's unique about this session is we're going to be doing a demo of an end-to-end scenario of everything that we've learned, but it's using Jupyter Notebook. So more reason why at the end of this session, when you go through the learning, the difference is you'll be able to see the similar demo or exercise, but this one is going to be in Postmod. So don't get shocked when you get to MS Learn and wondering, okay, this is different from what I saw.
Yeah. And when I first started out on my AI journey, I probably turned to the likes of Ruth and said, Ruth, what is semantic search or vector search or embeddings? These were things that we were all grappling with when we first started off on our AI journey. So if you're sitting here thinking, oh, crikey, I don't know what this is about, you've come to the right place. This session hopefully will provide some clarity, because I know Ruth and I, when all this starts off, it's new and fresh to everybody. So everybody is learning at the same time. So don't feel like you're behind the 8 ball.
Yeah. And another good thing is this is not a recorded session, as you figured out. This is live. So since it's live, it's meant to be interactive. So kind of like how Dave mentioned earlier, feel free to say hi and also post your questions in the chat, please. At any point, if you don't understand any of the concept, place your questions in the chat, and the moderators will do their best to answer your questions so you don't fall behind as we go along this session.
Okay, great. Yeah, so absolutely fire away and ask your questions. Okay, so this is a brief introduction, a high-level introduction into what you can expect to be covered in this Learn module. So the goals are, and maybe more importantly, the scenario is. So what the scenario for this Learn module is about building an online retail store. Now, you might be thinking, well, I'm not building a retail store. Don't let that get too much in the way. What we're talking about are really generic kind of terms, scenarios, but the scenario is geared around retail store, but it is applicable really across the board for pretty much most scenarios. And what the goal of this Learn module is, and for this retail store is, it's about building better search results for your users, for where they're going to query. And as we've kind of touched upon already, what you can hope to learn about, and this is particularly around something called Azure Cognitive Search, but you're going to learn more about and understand more about semantic search. You might be scratching your head, what's semantic search? Vectors, vector search, and embeddings. So that's what we're going to talk about. And as Ruth mentioned, we're also going to be using a Jupyter notebook. Now, what you'll find in the actual module, they're actually using Postman, and it actually works quite well, but it's not necessarily that clear when you're presenting. So absolutely work your way through that.
So
okay,
Dave, before you move on, one thing we need to point out is for Ignite, we have announced that we're actually retiring the name Azure Cognitive Search. So now it's actually called Azure AI Search. So if you see Azure AI Search, and we're probably going to be using it interchangeably, don't get confused. It's what used to be called Azure Cognitive Search. So that's one of the announcements made for Ignite this week.
Totally. And you can just imagine that Ruth and I are going to trip over ourselves for this. So, we're just going to drill back into that retail store. And again, most of this is applicable across industries. So if you think about enterprise search and building out solutions for that, you think about the number of documents and things like that you have, or Q&A, all those types of things. Maybe you've got your customers coming to your help desk saying, hey, look, I've got this problem. I need to upload this new product onto the website. Can you help me do that? And that's often done with things like Q&A support. So you've got agreements, documents, you've got policies, a whole range of documents out there that you need to be able to drill into really quickly to be able to help out other people inside your organization and potentially your customers as well. Obviously, things like catalog search. So we all spend our time nowadays on retail websites, and we want to make sure that when somebody's searching on a website, that they are hopefully finding the things that they are interested in. And that's a lot about what this is about, is making sure that your customers, or internal customers for that matter, can find the right information quickly and it's relevant to what their search inquiry. So catalog search is a really obvious one. Now, document intelligence. Now, most organizations are swimming in documents. And how can you extract insights from docs? And that's a really common thing people are do. Again, you might want to go summarize docs or understand what the policy implications are of government regulations, all those types of things on your policy documents or documents you have inside your organization. And the last part, of course, is around what we call knowledge mining. And this is typically around unstructured data. Or no, actually, that's not true. It's about structured and unstructured. So you think about, we've got a lot of structured data in our organizations, got databases and tables and spreadsheets and all those types of things with quite structured data in them. But you think about all the unstructured data that you have inside your organization. You might have audio files, you might have images, you might have videos, or etc. And you want to be able to potentially make those searchable as well. So this is this whole idea of being able to bring together structured and unstructured data together to really provide a really rich query experience. So that's the kind of thing we're trying to achieve.
It's funny, Dave, you're mentioning all of this. I can think of a lot of PowerPoint slides that I've done over the years. And when I'm trying to search for something on SharePoint, just to extract, and repurpose it, how hard it is. So I can imagine how a large enterprise would handle a large amount of data that they have.
Totally. Now, this section here wasn't actually in the Learn module, but we kind of thought it was kind of fundamental. And this was, I remember, when I first started out in this journey, people who have been in this, they banded around things like semantic search and and I was like, oh, I don't know what that means. So Ruth's going to talk us through about kind of what semantic search means.
Okay. Yeah, actually, there's so many search, it's hard to get confused. But when we talk about semantic search, one of the first things that you should think is searching for meaning. So we're used to the old way of searching things where we search by keyword and try and find meaning. But the unique thing about semantic search is searching for meaning based upon your query and trying to find things that are relevant meaning-wise to the search that you're doing. And it has a way of ranking the different results that it gets back. And that's how it returns the ones that are most relevant based upon the ranking in the results that it comes back. So semantic search actually thrives on vectorized data. So if you look at the different merchandise that a retail store has, if you look at the green represents all the products that either somebody will wear or with their hands, let's say their gloves, or their shoes. So that is a different type of merchandise. If you look under at the salmon, I think the salmon color, but we'll call it salmon color, but that represents more clothing, like maybe a shirt, a dress, a skirt, that sort of thing. And in blue, that's jewelry. So earrings, rings, and whatnot. So if I'm looking for a necklace, which is not listed there, the way the semantic search is going to figure out is, okay, which one has a more meaning in terms of necklace? It's not in there, but chances are things around jewelry, necklace, it means jewelry. So that's how it's going to quickly know where to go to search instead of searching all your data source. Okay, so that's semantic search. So to give you some kind of context in semantic search, let's say you're searching, I'm searching for my dream watch. So if I'm to submit this just using keywords, number one, my search is going to look for all the content that is related to dreaming. So all the photos that are related to somebody sleeping and dreaming, return it. And also watch. So look for all the watches. So since we're saying dreaming and watching and watch, does that mean the search is going to return an image of somebody sleeping with their watch on? That's the question. But realistically, the good thing about semantic search is it does understand the meaning. When you said, oh, my dream dress or my dream watch, what you mean is, what is my ideal watch if I'm to get a watch? So okay. It's not people sleeping with watches here.
Well, maybe it is just sleeping with a watch, but okay, that kind of makes sense. And what you're going to find throughout this talk is that semantic is kind of within everything we're doing. So we're going to talk about embeddings, things like that. Everything is semantic. So when you're creating embeddings or vectors or things like that, just keep in mind that these boil down to semantic search. So that's already kind of a key element. And that's really a way of improving the search matching and making sure you're getting the right results for whoever's searching.
That's a good point.
So the first thing we're going to do, or the next thing we're going to talk about is, okay, what is vector search? And we've got a nice, excuse me, a high-level diagram which kind of talks about an end-to-end scenario. As I said, this is kind of around retail, but it's pretty applicable everywhere. So what we're going to talk about is this is really in the context of Azure Cognitive Search, or Azure AI Search, as we now like to refer to it, and there's now a vector search built into that service, and it will enable you to do these scenarios. So if you start over on the left-hand side, you've got all your data sources. You think about the data sources you've got inside your organization. You might have images, you might have audio, you might have video, and you would have text. Now, often we mostly get probably a bit more fixated on text, but just keep in mind that there are ways of vectorizing images, audio, and video, as well as text. So the general process is if you take your data sources and then you create embeddings for them, and you use a model. So they're typically a neural network model. And that model will be specific to the data type that you want to create the embedding for. So you'd use a large language model, for example, for text. And then what that does is it creates a vector representation. Now, you remember you were thinking at school, never going to use vectors again. Well, we're back to that. We are thinking about vectors. And there are typically a 1 by n dimension-based vector. So you've vectorized out all your data types. And then what you need to be able to do is you need to, well, I've vectorized them. What do I do with them? So what you're going to do then is you're going to push them into, and there is a way of doing this, REST endpoints and things like that. You add those or insert those vectors into Azure Cognitive Search. So the idea is you take all your data types, vectorize them, push them into Cog Search, and then you would typically either have a snippet of document that would give it context, or you'd probably have some link back to where that original object was. So Azure Cognitive Search is not a database, it's a search index. I think it's quite important to get your mind around that. Okay, so we've now got our embeddings into Cognitive Search. So now we're going to pop across to the right-hand side of the diagram, and we're going to start off with what the user experience looks like. So we've got a user saying, okay, right, I want to find things in the store about bracelets. I want to go buy a bracelet. So what they do, the user types in that question, I'd like to buy a bracelet, please. And then what you do is you transform that text query into an embedding. And you use the same model that you used for when you created the index. So now with that query, you've created an embedding for it. You've got the vector representation for it. You then send that to Cog Search. Then Cog Search does what's called a nearest neighbor lookup. And we're going to go into this in more detail in a moment. But fundamentally, what it's trying to do is find the vectors in the data store that most closely represent or most closely match the vector of the query. Hopefully that makes sense. Mm-hmm. And then you get back a series of results back from Cog Search. Okay, so these are the appropriate documents or links or audios or whatever it is that match that query. And then your app would then send that back to your app and then present that back to the end user. So that's fundamentally what's going on. So you've got all these types of different vectorizations.
Dave, okay, is it fair to say the Azure Cognitive Search or the Azure AI Search has a vector database? The vectors are stored in a vectorized database?
Totally. Yeah, that's a really good point. So one of the new capabilities that went into Cog Search a while back was the ability to be able to store vectors. So that's a relatively new. So if you looked at Cog Search maybe a few months ago, it was missing that vector. And everybody wants to do vector indexing. So that's how you do it. Yeah. Or you go and fire up your own Redis server or something like that in the cloud. But yeah, good point. Thank you. Alrighty, so using vectors for search. So as you said, as you spotted in that previous slide, there's both an encoding and a query element to this. So you can use OpenAI, and OpenAI has a model called Embeddings. And you can use that model. It's there as a service, and you can call it. You can send your text to that model, and you'll get back a vector. But there are also a lot of open source models out there that you can use. And we're going to talk a bit more about those models a bit further in the presentation, just so you kind of understand why you might use OpenAI embeddings versus other models. And then you remember you've got to encode your query into a vector to retrieve documents. And remember, you've got to use the same encoding library or language model that you used to encode the data into the index. And as we kind of pointed out already, it's a semantic representation of data. So it's intent-based. My dream watch, it's going to look for maybe my ideal watch, and to give that a simple example. Okay, so we've also talked about multimodal, and this is just the ability to take different object types. And again, it's a term that's banded around, and it's one you might have heard, and you might be scratching your head to think, oh, crikey, what's multimodal? And it's really just the ability to go and search across different types of data or classes, so images, text, video, etc. And of course, in the world of global retail, you almost certainly need to be able to provide embeddings in multiple languages. And again, so that's something you need to be thinking about. Taking text, embedding that or translating that into a different language, and then creating the embedding for it and putting that in there. So then you get a great experience out there for all your users around the world. Okay, so the next thing we're going to talk about is what we call hybrid search. And again, a term you might have heard of banding around. Now, you remember Ruth talked a bit about keyword search. So keyword search is often the way that search worked before. So you would end up with searches about dreams and searches about watches, which is not really what we want. We want that intent, my dream watch. But we do also know that hybrid search, which is a combination of using vectors, excuse me, and searchable keywords, I'm now losing my voice, searchable keywords, to combine those together, and that often provides much better results. And then those results are merged into a single result back from Cog Search, and you get better results out there for your customer. Now, somebody asked in the Q&A about kind of optimization or best practices, and I'll talk a bit about this. And we'll go and see this in the demo as well. But one of the things you can do is really around filtering. So yes, you can go and provide a query into the data store, but more often than not, the user might have navigated through your retail site and selected, in this case here, the category of jewelry. And then what you can do is you can pass that category into the index and say, okay, before you go off and do your vector and your keyword search, I want you to subset that data down to that category. Then you go and do the vector search and the keyword search across that category, and then you get obviously faster results, but you're going to get better hit on what that customer or person inside your organization is searching for. So that's the kind of the idea behind that. And then we've got vector stores. Now, so we've talked about Azure Cog Search as a vector store, but it's not the only game in town. So just keep that in mind. You might know Redis. So Redis has vector stores in it. Pinecone is a well-known, as is 𝗦𝗽𝗲𝗀, and Elasticsearch. So just keep in mind. But the beauty of Azure Cog Search, or in fact Azure AI Search, is a service. It's a service in Azure. You just fire it up, and it runs as a service, and you don't have to worry about the health of that service. We worry about that health of that service.
Yeah, Dave, one thing to mention about the last slide, the very good benefit of using vector stores or databases is the long-term memory. So when it comes to LLMs do not have long-term memories. So when we train it, the model is actually frozen on the data that you train at that given point in time. Even when we fine-tune it with our own data, it is frozen at that point in time. So when we're dealing with vectorized database and embedding, the good thing is the data is constantly, being updated. So you're not going to have cases of hallucination because the data is fresh. So that's one of the benefits of long-term memory.
Really good point. Thanks for that, Ruth.
Yeah.
Okay, so Ruth, again, one of the terms I heard banded around was vectors. So it was embeddings. And then I scratched my head, what's a vector? What's an embedding? What's semantic search? So now we're getting on to embeddings. And Ruth's going to talk us through embeddings.
Yeah, embeddings is an area that I also struggled initially, especially when you're dealing with natural language processing. But part of embedding is a term called vectorization. And basically, vectorization is a general process of assigning unique vectors to a word or token. So when we make a mean token, just think of a word and its numeric equivalent. So a good analogy is when we used to look at glossary. I'm saying used to because like reading books, everything is online. But yeah, if you had a word and you wanted to look in the glossary, what did it show you? It showed you all the pages where it appears. So that's the same thing as like a token. It's just a one-to-one mapping of the representation in the vocabulary that that word represents. So the next one is embedding. So layman's term, embedding is just the process of converting text into a numeric array. If you have any other assets like video, images and whatnot, you're just transforming all of that into yet another array of numbers. So that's what embedding is. But the key thing that you should remember about embeddings is it's a data representation that is using machine learning when we're dealing with associating assets, text or images or relationships between the data that we're using when we're doing training. The areas that embedding is very effective and vectorization is the whole theme of this is, okay, finding similarities. Once you tokenize it, it tokenizes, the embeddings are basically a group of vectors that have similarities. So a good way to utilize this is with recommendation. So if you're searching for an item with recommendation, it'll take the item and figure out what are the texts or what are the other items that are closely related to this particular item. And it looks at word or keywords and it makes recommendations. Another way is anomaly detection. So same thing, relationships. There are groups of words or assets that group in terms of similarities. But if you have certain ones that are like way off, two different embeddings that are not closely related to each other, that's where we see outliers, and that's where you can easily spot anomalies because the distance between the relationship is more further apart. Same thing with search.
So a way of thinking about that is maybe you've got a product description, which is a red dress, but in the description, maybe it refers to a blue dress. And you could find things like that within inside the anomalies. I think maybe we should just move on to the next one and maybe just talk a bit more about tokens.
Yeah, so the slide that we just came from is pretty much, this actually is a better explanation and representation of it. The sentence that we have is her dress is a prom dress. One thing I want you guys to look at is the word dress appears twice. So the very first step when we have words is converting it into a token based upon the vocabulary that we have. So if you notice the ID representation or the numeric representation of the dress is the same. The letter A is going to be mapped to its own representation. So that's how the very first step is tokenization. So converting the word into text. The next thing is embedding, the third box at the bottom. So embedding is vector collection of vectors, and is basically putting things that are similar together and grouping them into vectors. So if you look at the initial diagram that I showed, we showed jewelry, we showed clothes, we showed maybe apparel that you wear with your hands or feet, that sort of thing. So all of those different quadrants will fall under different vector embeddings, because embeddings only contain things that are similar, groupings that are similar to each other.
Okay, and also, and again, the first time I looked at these, people started talking about tokenization. I thought, what's tokenization? And again, it's just kind of splitting up words. In OpenAI for tokens, typical length is around about 4 characters of a word. So a word might be broken up into multiple characters. Now, the other thing about this is you might be thinking, well, this complexity, do I have to deal with all this? No, you don't. The language models deal with this for you. So you pass it in some text, and behind the scenes, this is kind of what it's doing with the text that you're passing through.
Mm-hmm. So to elaborate on, thanks, Dave, for the clarification. The next thing is when we're talking about embedding, so with the socks, boots, socks, shoes, and camera, just think of plotting all of that, looking at a graph notation. And when we look at boots, boots are more closely similar to shoes. And when we look at socks, socks are a little further, but what they have that are similar is those are things that you can wear on your feet. If I come in looking for a certain type of camera is way off. So this is an example of a cosine similarity, where you're measuring the distance between words and saying the closer it is, the higher the ranking of the match for its similarity. So this is another way of thinking of embedding. This decimal has a meaning, and this other decimal will have a meaning. So these different variables or numbers, if they're similar, that's how the grouping happens.
So one of the ways I like to think about this too, Ruth, is most of us cannot think past more than 3 dimensions. Like we can think of X, Y, Z. We can kind of visualize that in a cube and things like that. But most of us cannot visualize a vector with 6 elements in it, let alone a vector with 1536, which is the number of elements or numbers that are in an OpenAI embedding. But the way I like to think about it, bring it back to really simple principles. Most of us are pretty comfortable with longitude and latitude, or getting those longitude, latitude numbers. We go into a map application. We say, hey, look, find the cafes around me. And you can imagine what's going on. There's a circumference being calculated, and then it's finding within that longitude, latitude. It's basically doing a vector lookup and finding it, but it's just a 2-dimensional lookup. So just think about 2-dimensional, we can get our heads around. 3-dimensional, yeah, we can get our heads around. Past that, most of us can't think any more dimensions. And Ruth also mentioned something called cosine similarities. And I just want to talk about that. So you'll hear that banded around a lot as well. So it's mostly and often cosine similarities, which is an algorithm which is used, which is built into these engines or built into pandas, data frames and things like that, which is going to go off and do this match and find the vectors for you. So all the maths is kind of done for you. Now, a question came up in the Q&A about what's the difference between vectors, Azure Cognitive Search, and the likes of Redis. So, I mean, fundamentally, they're both doing cosine search, cosine similarity search. But the difference is that Cog Search or Azure AI Search, it's a service. You do not have to go and manage it yourself. Whereas the likes of Redis and those other services, you typically go and have to go and manage those yourself. So that's kind of what the difference is. You're buying into, with AI search, you're buying into a managed service. With the likes of Redis and things like that, you'll typically say, right, I'm going to host that in the cloud and I will manage it. That's typically the difference why you might use AI search versus another vector store. Now, what I want to talk about as well is that we talked about embeddings. So I just want to talk about a little, just so you kind of understand, because we've mentioned a couple of times embeddings and OpenAI embeddings. Now, we kind of touched upon this very briefly before, which was about in OpenAI, there is an embeddings model cunningly called embeddings. But it's also worth appreciating that there is a lot of research going into embeddings models. So I've actually just linked us off to Hugging Face, and I've got the link at the back of the end of the slide deck. But there are a lot of models, and there's a lot of research going on in this area. And you may find that for your use case, well, there may be reasons, for a whole range of reasons, from cost, for running things on premise, that you might want to use an alternative model. And you can see through here the models and how they behave and what their characteristics, and there's a ranking and things like that. And you can see the dimensions and the sequence length of the tokens that you can send through to these things. But the really important thing to remember, this space is changing really quickly. So be careful betting on the latest and greatest. Particularly if you're going to embed a lot of data, you probably want to use a stable model. And that's really where OpenAI embeddings is a great model, because we are going to manage that lifetime for you to make sure that the model is there for both when you indexed your data into a search index, as well as when you're going to query it. So you remember, those models have to be in sync. So we're kind of managing that problem for you. But that's not to say that OpenAI embeddings is the only game in town, and you can play it and have a look around here. And just interesting, these are open source models. There's great documentation about how to use them. So just keep that in the back of your mind, that you may have a use case where OpenAI embeddings is just not doing it for you, or you need to run it on-prem, or maybe there's cost considerations, a whole range of reasons it could be.
Yeah, one thing I noticed, Dave, in the last slide, I think it was the length of the sequence length of the vectors. If you notice, if you scroll up, the embeddings dimension may stay the same as I think it's 1054, but the sequence length changes. So if you have like a different embedding, the vector size would be different. So obviously it's not going to be able to be a one-to-one fit, especially when you bring in the question. Yeah, the vectorization is going to be thrown off.
And you can see here, so this one I've highlighted at the moment, row 19, that is the text embedding 𝗦𝗽𝗀002, and that is the model name for the OpenAI embeddings model. And you can see it has by far the largest sequence length, and that may be something that you need. So again, just kind of keep those things in mind. Super important to understand. Alrighty, now just bring back the slides. Okay, so that's Hugging Face. Now, I think this is me, isn't it, Ruth? Yes, I think it is. Okay, so the next thing we're going to talk about is search indexes and how you create them. So imagine you've got a product description, and you want to make that available to your end users to search. And you can see in here, I've got a bit of leptosporium, and lorium ipsum, I should say, making words up as I go. And this is the product description. And then what you would typically do is that you would typically chunk up this product description. Now, to chunk or not to chunk up things really depends on a number of things. One, how long that, in this case, a product description is. If it's a very large product description, it might just be too large to be able to send it into the embeddings model for it to get the vector back. So there could be just technical reasons like that. The data is just so long. The other reason might be you want to increase the granularity of the search, in which case it might make sense to go and chunk up your document into multiple chunks, because that's kind of improving the granularity. And of course, there's a fine line between chunking up too much and having chunks that are too large. Now, so in this case here, what we've done is we've just chunked it up into 3 chunks. We're taking the original product description, we've just chunked it up into 3 chunks. Now, you might be thinking, why has he highlighted this text in red? And the reason behind this is what's called overlap. Now, because we've taken a chunk, and basically, well, we're taking a chunk of each this and broken this up to 3, we might be losing context. And it might just be that the next sentence and the next chunk might have added quite a lot of value to the context of the initial chunk. So what you tend to see is what's called overlap. And it's done to make sure that each chunk has a degree of context from the next chunk. So when you go into libraries, like there's Python libraries for splitting up text and things like that, you'll often see terminology like chunk size, and percentage overlap. And this is what the percentage overlap's about. It's all about providing context. So making sure that when the query is that you might have had that bit of that, but a little bit of extra context might have helped. Then we take all those chunks and we ship them off to OpenAI embeddings, and we get the vectors back for them. And then what we do is we take those vectors and typically some reference information. In this case, we're actually going to take the chunk, and we'll put the chunk of text and the vector into the store. But if it's an object like a video or an audio, which doesn't really make sense to put it into the index, you probably put a reference, a URL to where you're going to find that item. So now we've got that in Cog Search. So that's pretty much what goes on.
So real quick question on that. When we're chunking, is the goal to make the search a little more faster, like when we're querying? What's the benefit of that?
Yeah, and we were talking about this before, actually, weren't we, Ruth? And actually, this, I think, was a project. Now, there is a line between, if you put lots of different chunks, if you chunked up a document into a relatively small piece of chunk, you would end up with a lot of index.
Yeah,
and a lot of vectors that you're then going to have to do. The search engine is going to have to work a bit harder because it's having to do these cosine similarities across a bigger data set. So again, it comes down to your trade-off. How much data you've got, how much you want to pay for the index for that. It could be a consideration, and the performance. And again, and typically you'd probably add some sort of category, just again to help with the. So you might say, again, this is jewelry, or this is books, or these are motor cars, or whatever it is you're going to be buying on the retail store. Again, just to help improve the performance. But yeah, totally good. Yeah, excellent point. Now, just as a kind of like a screenshot to give you a bit of context, this is just the Azure Cog Search, or now formerly known as Azure AI Search, and it's just a service sitting in Azure, and it's providing the index. And you can see this index it's only got a very modest amount of documents. It's got 108 documents, and it's taking
that's a lot of documents.
Yeah, but you think about it, if you're a retail site, you could have like millions of documents. So this could be a pretty big collection. But yeah, what you'll find in the module learning is that there is a pretty decent. There's a good way of uploading this index, and you can play around with yourself. Now, Ruth, do you want to talk us through queries? How to do queries?
Sure. So everything that we've spoken up to this point is the process of vectorization. When the data comes in, what's the process of storing it into the vector database? So now the question is, when somebody comes in and submit a search, so let's say I'm looking for a bracelet for a friend. The question is, this is text. I have numbers, numerical values stored. So how exactly are you going to find a match when the end result is either going to be a video, text, or image? So if you click on the next image, the next step.
Ruth, I'm going to chip in here because there's a question that came up, which is actually really relevant to this. So the question came up, am I embedding by tokens or words? And maybe you can touch upon that, Ruth, because I think it's relevant to this. So I think it's a great question.
That's a great question. So everything comes in tiers. You start by words. So at the back of what you're dealing with is you're going to have a corpus of vocabulary. So your vocabulary, each word in your vocabulary has a unique number. So the very first thing is taking the word, and when we're tokenizing it, it's just a mapping between that word and the numeric representation in that vocabulary corpus that you're using. So that's number one. Number two is, go ahead.
No, I was going to say, it's also fair to say that what's happening behind the scenes, words like bracelet or looking, they would typically be split up into multiple tokens, or they will be split up into, so looking will be probably split up into look and then ing. And that's going on behind the scenes. You don't have to worry about that. You're just supplying text. The model is tokenizing, and different models will have different strategies for tokenizing. Bracelet, for example, would probably be split up into, what do you reckon? Bracelet.
Actually, there'll be one word equivalent. So it's kind of like looking in the dictionary. If we scan through the dictionary, if every word had a unique number, that's your vocabulary corpus. So you just extracted it into a numeric representation. Now we're trying to find, okay, what other words do we have out there? Where can we group this particular word? So that's the embedding. That's a machine learning part that finds areas where, okay, which bucket can I place this word in based upon its meaning? So kind of like how I was mentioning, okay, I have a text query. I bring it in. I have to go through the same process. I need to create embeddings. So for each of those words, tokenize it and embed it. Then go to the database. So one thing that Dave mentioned is we are storing the embeddings into a vectorized database, but we also create an index. And that index, when we're inserting the data, that's when that index is created. And at the same time, there's a machine learning algorithm that is pre-calculating the nearest neighbor. So by the time you come with this embedding, it happens very fast because it's going to go directly where to find the information, find the response. And if we look at the query, we see two results. The very first one, the score is 0.95. The second result, the score is 0.91. So as you can see, these are all high scores. But if you're to rank and pick the best result, we'll pick the first one. But just think of a search engine. What happens when we submit a query? This is exactly what's happening. You are getting a ranking based upon relevance, meaning, and similarities to what you're querying. Yeah.
So what I would do when I'm building applications, I tend to have like a threshold in mind. And I'll say that, look, if anything goes below a threshold of, I don't know, plucking a number out of there, 85%. If anything goes below 0.85 from a score that I get back from the vector data store, I kind of think, do you know what? The relevance of that value that's come back, it's not that relevant. And so in which case I just don't tend to show it to the end users. Now, actually linking all the way back, I just want to make a comment that we talked about tokenization. There is actually a website. If you go searching for OpenAI tokenization, and that'll take you off to a website, and you can copy and paste text into that page, and it will show you how it's going to be tokenized. So again, and you can calculate cost, for example, can help you get a bit of sense, because you tend to pay by tokens. Things tend to be rated by tokens. So
and one thing to
add
is a lot of these machine learning frameworks already have a function for tokenization. So if you look at PyTorch, PyTorch has a tokenizer. So automatically you just need to tell it what your vocab corpus is and give it a word, and it'll tokenize it. And if you want to reverse back to the original word, it does both ways. So a lot of this is already done for you. You don't need to boil the ocean.
That's a really good point. There are a great set of libraries out there for multiple languages that abstract away the complexity, but it's really useful to know what is going on. So you can, has a cost implication, has a performance implication, but yeah, most of the stuff you don't have to deal with the nitty-gritty for this. Okay, so as you can see, I've just flicked across to a demo. I think we've got about 10 minutes to go.
Okay.
And this is one of the Jupyter notebooks that will be linked to in the back of the slide deck. So the first thing in here, I'm just doing this is a Python Jupyter notebook. And the main thing in here, you'll see I've got various keys off here for getting to Cog Search, etc. But I've also got the key that I need to get to OpenAI. So this is the Azure OpenAI key. And there will be an endpoint or the URL for the OpenAI service. So you need to know those when you go and set up the Azure AI search service. When you go and set up the Azure
AI search.
OpenAI service, you'll need the key for that. Sorry, I eventually got there, just to confuse us all.
Yeah.
But in this case here, because we're calling on the embeddings model, I've already set up an OpenAI service inside my Azure subscription. So we're going to run that. We're going to run that cell. So that's imported all those. And then what this is going to do, imagine, so this is a bit of text about a bracelet. So imagine this is the product description. And again, this is obviously you would probably have a larger product description, but you get the general idea. A stunning leather watch. So this is the content. And what I'm going to do is I'm going to pass it to OpenAI, the embeddings engine, and then get back a vector. And the query embeddings will be this vector. So remember, we're using vectors and embeddings, a bit interchangeable. An embedding is a vector which has been generated by typically a neural network. Okay, so we're going to run this off, and that's called off to Azure and the embedding service. And you can see it's brought back a vector. So this is a vector of 1 by 15, 36 numbers. So that's what a vector is. So it just looks like that. So you don't have to worry too much about it other than know it's happening. So remember this, and then what we would be doing, we would take this, they would take this vector that came back from calling OpenAI embedding service, and then we would insert this vector along with this content. We would put that into the index. Now, in this example, I'm not doing that because I've already got the loaded up, the index loaded. Okay, so the next thing, what I'm going to do is the same principle here. I need the OpenAI key and I need the endpoint. I need to tell it the embedding engine. I'm going to run that cell. I've got something there for doing some printing. And what I'm going to do next is I'm going to get the embedding for this document set is actually not particularly retail focused. This is actually an index about Azure. And we'll run that and we'll get the embedding back for this query that the end user put in, getting started with Azure Search. Okay, so we've now got the embedding back. And then the next thing we're going to do is we're going to formulate a request that we're going to send off to Cog Search. And you can see that we're passing in the vector that we got back from OpenAI. So passing in the vector. The field that we're going to do this vector search on is called content vector. And we're going to return back a maximum of 5 fields or 5 rows back from that. And the fields we're going to return back a title, content, and category. And then we're going to set up the URL to call the search, and then we're going to call it down here. So we'll run this, and you'll see it's quick. And mind you, it doesn't have a lot of index. It's really quick. And you can see that this is the category that it brought back. This is the score. So the category here is AI and machine learning. This is a score, and this is a text. And in the interest of time, we'll keep moving on. Now, a question came up about optimization. So remember, what we want to do in this case is we want to provide a filter. So imagine you're going, I want the category of jewelry. In this case, I want the category of analytics. So I'm subsetting out the data, and then I'm going to do the query across that data set. So we'll come down here, and you'll see there's no magic below there. We'll run that. And now that's gone against Cog Search, and you'll see that the category is now just analytics, or it would be just jewelry or whatever it would be. So hopefully that kind of gives you a bit of a sense of how that's working.
I really like that demo.
Yeah, so it's really easy.
That's a good one.
You'll find the Postman, we found the Postman demo was a bit opaque. So we've got these notebooks here just to make it a bit easier.
Okay.
Alrighty, so we're in the
So
home
we
screen.
have 5 minutes left. So we'll try and make this knowledge check fast and sweet. But this is really to test how well you guys were listening to what we're saying, or how well we did explaining the concept. So the very first question, oh yeah, so before we go through the questions, everybody scan the QR code to also vote the answers, or use the AKMS link and pick the answers. At the end, we'll figure out whether you guys paid more attention and understand this, or we're the ones that need help and really need to take the lesson again.
Yeah, well,
So Dave,
yes, it needs some help.
yeah. So Dave, I'm going to ask you the first question, and the audience, I'm assuming they're all ready. So regarding vector search, when would you use a vector search? A, to create a search to match text input, or B, when you need to find matches across different types of data from a search index.
Okay, I'll have that one.
C, to upload and index a document library. Which one do you think?
Do you know what the worst thing about these questions? They all could be true, but one of them's more true than the other, I suspect. I don't know. What do you think?
Everything is looking like what we discussed, but I'm going by the different types of data. That's a key word.
Yeah. No, we did touch upon that a couple of times. And in the interest of time, we did talk about this. As you remember, it's not just text. It could be images, it could be video, it could be audio, it could be a whole range of different things where you've got models where you can create embeddings for. So yeah, so hopefully you too came up with, this is probably the best answer, but the others are kind of true as well. Okay, so on the same link, so hopefully you're on aka.ms/polls-A. So remember, it's a case sensitive capital A. What do you need to run a successful vector query? Now, I did labor this point a bit in the demo, if you're wondering why he's laboring the point. Your search service URL and your admin key. Okay.
I think you need an Azure subscription to do anything.
Well, yeah, I'm going to need one of those. Yeah. Your storage account, look, I'm going to give you a bit of a hint. We never mentioned storage accounts.
Oh,
so you can eliminate that one. You can eliminate that one out of your choices.
So I think it'll be too simple to say Azure subscription. So I'll go with the service, search service URL and the admin key.
Totally. So you did probably see me laboring the point in the demo. That you need the service endpoint for OpenAI, because you remember I was calling the embeddings, and for the search and for the cog search, and you need the admin keys. So you need those for both the search as well as OpenAI. So you need those keys, and clearly you're going to need an Azure subscription to use this as well. But for once in your lifetime, if you played on with Azure for a while, you actually don't need a storage account. Alrighty, last question.
So, final question. What type of vector search would you use to capture semantic search? A, a text search, B, a similarity search, or C, a code search? I don't think we talked anything about a code search, did we? Oh, am I giving out? I'm just thinking out loud, but this is, you're in the hot seat, sorry.
We talked about text search, it could be that.
Yeah, we talked, every other word was around text.
It was, but we did kind of labor the point around cosine similarity. Yeah, look, I'm going to put us all out of our misery. Hopefully you got to similarity search. Whoops, let's make sure I'm on the slide. Hopefully you too got to similarity search. Yeah.
Nice.
look, you can do models for code search and things like that, but that wasn't kind of covered off in this. And obviously you do text search, but similarity is kind of what you're really trying to do around this, capturing semantic similarity. Sweet.
Awesome.
Alrighty. So in summary, Ruth, go for it.
So hopefully, now that we've in, you've been able to understand semantic search, you understand vector search, you understand embeddings, and looking at Dave's wonderful demo using notebooks, you understand how vector search works when you have a vector store, embeddings, a query, and data. One of the announcements that we're excited to make this Ignite Week, number one, integrated vectorization is now incorporated into Azure AI Search, aka Azure Cognitive Search. Then with the announcement, we changed the name of Cognitive Search to Azure AI Search. Then another thing you're going to find exciting is you'll be able to bring in your customer managed tools, especially when you're dealing with APIs and secrets and whatnot. So those are the announcements for this week.
Ruth, I think you said custom managed tools. I think you meant keys.
Oh yeah, customer managed keys. Yeah, there are many tools out there that achieve this, but yeah, we're running out of time, but I know the audience knows the semantic meaning of what I'm trying to say.
Touché.
I know we're running out of time, but audience, please just take a photo of the screen. Dave's wonderful Jupyter Notebook demo is on GitHub. You can find it there. If you want to find out more information about Azure AI Search, somebody asked about does it support CLI? You find all the information there. If you want to figure out all the embeddings models that we have for Azure OpenAI, we have a link there, and also Hugging Face URL. So if you try something Azure embeddings, also compare it to Hugging Face embedding and see what the results are.
And you hopefully have got a screenshot for this already, but this is the link off to the Learn module that we've been talking about. Do check it out. It's a good module. Some places a little bit opaque, so that's why we wanted to make this a bit richer than maybe you got out of the module. And also, there's some other sessions coming along. And also, don't be, just keep in mind, if you head off to aka.ms/learn@ignite, there are some skills challenges to get involved with. So do check those out, particularly if you're a student. Students love these. It's a great way to kind of show and kind of dig into these things that you just learn so much. I actually love doing them myself. I think, oh, why did I do that sooner? Depending on where you are in your career, also getting certification, super useful to get this. And of course, everybody wants to talk about AI today. All organizations are really trying to get their head around how to learn more about AI, and particularly around these large language models in Azure. And there are a whole lot of learning collections that you'll find at that link as well. So do check that out. And great. So I know we're like 3 minutes over time, so sorry about that. So hopefully you enjoyed the session. We will hang around a little bit longer for Q&A. And wherever you are in the world, thank you so much for joining us today. Enjoy the rest of Ignite. There's so much content. It's such an exciting area to be involved. And hey, thank you so much, Ruth, as well, for being my gracious host.
Yeah, thanks, guys, for joining this session. I hope you found it very valuable. And I'm sure you guys can't wait to run and start the MS Learn module right now. Bye, everyone.
Alrighty, take care, everybody. Cheers. You have a good day.
Bye.